Hello, fellow chemists. In this video, we're going to take a look at types of chemical reactions. This is labeled as a basic video because there's no background information that you need to know to understand what I'm going to be lecturing on today. So let's get started. I often tell my students to think of chemical reactions almost like cooking recipes. So up top here, I have a recipe written out. You have your ingredients or your starting materials, your dough, sauce, and cheese. And then you have your conditions, which would be 400 degrees Celsius for 20 minutes. And then you get your product, which is a pizza. Well, you have your reactants, your conditions, and your product. It's the exact same thing for a chemical reaction. So you could take calcium plus sulfur, that would be your reactants. Your conditions would be represented by this arrow. You'd have 25 degrees Celsius for 15 minutes. And then your product would be CAS, the two compounds combining together. And just like in cooking, where you can classify different recipes, like this would be classified as an Italian recipe, primarily because of the types of ingredients used. Well, you could also have, say, an Indian recipe, which would have different types of spices or sauces being used. You can also categorize chemical reactions based upon the types of starting materials that are used, how those starting materials interact with each other, and the type of product that is produced. And there are 5 main types or categories of chemical reactions. And we're going to take a look at each of those 5 types, and then we'll do a couple examples where you have to identify which category or type of reaction the problem falls into. So the 5 main types of chemical reactions are synthesis or combination. That's where you're combining two compounds together. Decomposition, which is kind of the opposite of synthesis. That's where you're breaking compounds apart. Single replacement, often called single displacement. That's where you have a molecule that switches place with another atom. And then double replacement or double displacement, that's where you have two molecules and they're both switching parts with each other. And then combustion, and that's when you have some type of a hydrocarbon reacting with oxygen, producing carbon dioxide and water. So let's first start off by drawing some generic examples of each of these types of reactions. So for synthesis, you would have one substance reacting or combining with another substance to form a larger molecule. And then in decomposition, it's just the opposite. You have a larger molecule that breaks apart down into its initial components. Then if we take a look at a single replacement, you have a larger molecule, and then you have a single atom or element, and it switches places with one of the atoms or elements in the larger molecule. And then in a double replacement, you have two molecules, and they both switch places. I often tell students to think of single replacement and double replacement as people at a dance. So this would be a couple dancing here, A, B, and then C asked to cut in. So now A and C are dancing, and B is by itself. This would be two couples dancing, and they both switch partners when they're dancing. And then the last one, combustion, you have some amount of hydrocarbon. And hydrocarbon is just anything like paper, wood, cardboard. They're all made out of hydrocarbon, some amount of carbon and hydrogen mixed together, placed in the presence of oxygen. And then they will cause a fire, and the product is carbon dioxide and water. Now you may say, hey, I've seen fires burning before and I don't see any water getting produced. Well, if you look above the flames of a fire, you'll notice that there's those wavy lines. Those are gases being produced. And the two gases when a fire burns are always carbon dioxide. That's the same thing that you exhale. You breathe in oxygen, you exhale carbon dioxide. And then it's also water vapor that's produced. So whenever something burns, it is actually producing water in the form of water vapor. All right, so these are some generic examples of the 5 types of reactions. Now let's take a look at the problems I have down here. and see which categories each of these reactions would fall into. So if we take a look at the top one, it says you have two CuO, and then it forms copper and oxygen. So you have a larger molecule on the left, and then on the right hand side, they break apart. Well, that's kind of following the decomposition example that we have up at the top here. So this is an example of decomposition. We take a look at the second one. You have AgNO3 and you have NaCl, and then it goes to AgCl and NaNO3. Well, really what's going on is the Ag and the Cl are switching partners, and the NO3 and Na are switching partners. So this is a double replacement or double displacement. And if we take a look at the third one, you have CH4 plus O2, 2O2 yields CO2 plus 2H2O. Well, this is a hydrocarbon, some amount of carbon and hydrogen, and it's interacting with some amount of oxygen, and you're getting carbon dioxide and water as a product. Well, that is by definition a combustion reaction. And if we take a look at the second to last one here, we have Fe, which is iron, plus CuSO4. And then now the copper is by itself, and the iron is with the SO4. So basically, the iron and the SO4 underwent a single displacement or a single replacement. So this is a single displacement. And then the very last one, we have calcium plus sulfur, and then they're combining together to form CaS. Well, this looks like the first one up here, a synthesis, where you have two simple molecules combining together to form a larger molecule. So this would be a synthesis or a combination reaction. All right, so we've seen an example of each of the 5 types of reactions. We've seen what differentiates each of the 5 types of reactions. So hopefully anytime that you see a reaction in chemistry now, you can kind of break it apart as either synthesis, decomposition, single replacement, double replacement, or as a combustion reaction. All right. That's it for this video. I hope you learned something. If you did, like and subscribe, and I'll see you in the next lesson.